Alacrán hidráulico. Cápsula científica transversal con idiomas. Integrantes: García Campos Frida Daniela y Lara Martínez Bené Montserrat del grupo de quinto.
Pascal's bubble is the name of a hydrostatic experiment allegedly performed by Blaise Pascal in 1646. In the experiment, Pascal allegedly inserted a long sandpipe into a barrel filled with water. When water was poured into the sandpipe, the increased hydrostatic pressure caused the barrel to explode. In 1647, Pascal learned of Evangelista Torricelli's experimentation with barometers after replicating an experiment that involved placing a tube filled with mercury upside down in a container of mercury. Pascal questioned what force was keeping some of the mercury in the tube and what was filling the space above the mercury in the tube. At the time, most scientists held that inside of a vacuum some invisible matter was present. The main application of Pascal's principle is the hydraulic press. This is made up of two rigid wall containers, each containing an incompressible fluid, and both containers are connected at the bottom. In the project that we are going to present to you, we treat Pascal's principle thanks to the force that is applied to the syringes, and these are connected to exert pressure and generate movement.
It is a job that has degree of difficulty since you have to calculate the amount of liquid that is needed in each shingle to be able to make the parts of the scorpion move.
Pascal's principle. When a pressure is exerted on a fluid, it will be exerted with equal magnitude in all directions and in each part of the fluid.
Blaise Pascal was a French mathematician, physicist, philosopher, Catholic theologian, and apologist. He was born on June 19, 1623 and died on August 19, 1662 from stomach cancer. His studies in hydrodynamics, hydrostatics, and atmospheric pressure led him to invent this syringe and the hydraulic press and to discover Pascal's law of pressure.
Realization of the project. For the realization of the project, teacher Wendy gave us a project for a past generation, to which we modified hoses, support, dies, among other delights. For its realization, we used 5 externals and 5 internal singles, 4 of them with 4 milliliters of water and 1 with 4.5 milliliters, with which we have enjoyed pressure to move the joints of the scorpion. We also gotten through the pressures, tube kits, silicone bars, silicone joint, paint, brushes, sandpaper, zip tapes, water, and dye and tape. The modification to the scorpion took around 5 hours with the work of 6 people, each one in chain of different activities such as paint, melting, calibrating, and gluing.
For this project, we used 5 syringes so that the scorpion had a good movement. Syringe 1 and 3 moved the scorpion's pincers. The syringes 2, 4, and 5 moved the tail of the scorpion.
Pascal's principle in everyday life. When you inflate a balloon, you may have noticed that it inflates uniformly. The pressure you exert with the propellant air is transmitted through the air in the same way. When pressure is exerted on a syringe, for example with a vaccine, The fluid enters the body evenly. In the workshop, to race a car, they use jacks that work on a principle very similar to the brackets or the hydraulic press.
In conclusion, our project moves three of its parts thanks to 10 singers, an hydrostatic pressure and altis includes Pascal principle, which was the main objective to learn more about this principle and put into practice. Thanks for your attention.
Next, we will show you how our project moves to demonstrate the principle of Pascal.